Okay, guys, number 3. I think most of you started working on the All right, so for number 3, they said that you have a rectangle, one side is 50 plus x. They didn't tell us anything on the other side. So I just made that equal to y. You didn't have to, but I'll tell you now what I did after that. But they did tell us that the perimeter was 500. So what I did was I set up an equation for the perimeter of the shape, right? So if I have 2 y's, and the physical perimeter, you just add all the sides together. So y plus y would be 2y, and then 2 of those, 50 plus x, and another 50 plus x. All of that together should equal the perimeter, which they did give us, right? Which was 500. So from there, then, multiply my brackets out, and I got an expression for the other sides of this rectangle in terms of x. But it is very important when you're doing optimization. Remember, you're going to have to find the derivative of the area. So if you have a 50 plus x and then times by y, you have 2 variables, you can't find the derivative of that. Okay, so for these questions, I'm just going to make a note next to this here. I don't think we have actually written that down. Have to express both sides in terms of x, in terms of one variable. You didn't have to work with the y, you could have just figured out like the other 2 sides would have to be 2 minus x, that's fine. Then from there, that's actually not even step 1. Remember, yesterday we wrote down the 3 steps, right? Step 1 would then actually be to find an expression for the area, because we're asking for the maximum area, okay? So the area of a rectangle, length times breadth. Right, so once you have your length in terms of x, you can use that. So length times breadth, multiply that out, and just simplify. That is actually step 1. All right, finding an expression for the area in terms of just one variable. Step 2 is then to make the derivative of that expression, that area, equal to 0, and use that to solve for x. And in this question, that's actually as far as you have to go. They just ask for the value of x. They don't ask for anything else. Questions on the Yes. Yeah. All right, number 6. Want to see that answer again afterwards? So for number 6, they ask us to show that the volume of that cylinder can be written in this way. So I did make you guys just write down the volume of the cylinder is pi r squared times h times the height of the cylinder. So the radius and the height were actually both given in this. So that was quite nice. So you just have to sub them in. So it's pi times the radius squared, so x squared, times the height, which is 300 minus x. And then all you have to do from there was you have to multiply pi x squared by 300, and then pi x squared by negative. Right, and this is also what they asked you to get to. Then for B, they wanted to know which dimensions. So what was the radius and the height be to have a maximum volume? So volume must be maximum, so you take this expression for volume, find the derivative and make that equal to 0. So guys, what I did here, just, I think some of you are getting a bit confused when there's a pi as well. It just seems like there's quite a lot going on. So I just wrote them the other way around. That's all I did from this line to this line. It's not a necessary line, you don't have to do that. I just wrote the x squared term in front, which was negative, and then the x term after that. Then I divided through by negative 3 pi. right? Remember pi is a number, you can divide by. So I just divided that term by negative 3 pi and that term by negative 3 pi. So I ended up with that, which is just, now you're going to have to take out x as a common factor. We get x minus 200. So then for x equals 0 or x equals 200, x equals 0 is invalid because if your radius is 0, then you don't have a shape. So you have to say that that one is invalid. That's solving for x, but because they asked for the dimensions, you still have to say, okay, the radius was x, so that's 200, and the height was 300 minus x. So 300 minus 200 is 100. Okay, I'm not going to mark 7 now. Those of you that did it can come get the answer from me later, but I'm not going to waste time anymore. All right, we're doing one more topic, rates of change. There you go, there's the heading, please copy that now. Okay, this is the second application of calculus. There are 3. So we've done optimization, rate of change is the second one, and then on the first day next term, we're going to have to do calculus of motion. Now, if you hear the words rates of change or just rate of change, if we're thinking back to a graph, the rate of change of a graph is basically the gradient of that graph. So how the curve of the change is essentially. If you're thinking of like a parabola, right? How does that parabola change? It has to do with the gradient of it. So if you want to, you can make a note here. Rate of change is the same as the gradient of a graph. And hopefully we remember that the gradient is always the derivative. So as soon as you see in any question the words rate of change, or if they say at what rate is this thing changing, all right, then I can always use the 3 words together, all right? But if they talk about rate of change in any way, then you're going to have to find the derivative. So you'll see now when we do an example of how they actually ask it. But this is just also something that came up. I can't remember now if it was in last year's paper or the year before. But there was a question on average rate of change and no one knew how to do it. So do you guys remember the first lesson that we did on calculus? I know it was a long time ago, but it was average gradient, right? Where we literally used the gradient formula. So we did change in y over change in x. So if they're talking about the average rate of change, then you're going to have to use your gradient formula. So I didn't try changing y here because it's not always going to be a y, right? You'll see now when we're looking at this first example, they're talking about, what is this? Volume of water, all right? So in that case, the y would be the volume. So that's why I put the function here, all right? So the change in whatever the function is over the change in whatever value is set. See if I can find an example. It's not really common for them to ask it like that, but it might come up. So I'll see you here. And we can just do an example quickly next turn. All right, the example that I want you to write down, you can just write down. Sorry, that is quite a lot of, oh dear. I need to do that. That is quite a lot of writing. Can you read that? Is that too small? Write down the stuff and then just A. And we can do the answer to A and then we'll write down questions. And if you've come into this class to just be on your phone the whole time, then you can just as well actually work. Phone can be away in your bag. Finding. All right, a tank of water has water being pumped into it at a certain rate. So there we already see the word rate, right? So we can already start thinking maybe we're going to have to work with derivatives here. And water being pumped out of it at a different rate. The volume of water in the tank can be described by this equation. So they have given us an equation there. That is the function, right? That's the function that we work with. Where T is the time in minutes and V is the volume measured in liters. So for A, they're just asking how much water is in the tank initially. Let's write down A and then we'll do that. If you think you have an idea of how to work that out, then you can do it along. Just how much water is in the tank initially. What does that mean? Initially, it's at the start of the whole experiment, I suppose, right? So what would the time be? How many, what is time again? Minutes. How many minutes would have passed if you're saying initially? 0, okay? Right? So what do you think you're going to do with that 0? Plug it in. Good. All right. So I'll write it down now as well. Is everyone done? Yes. Okay, that's fine. Okay. Just rewrote the equation there. Now they're asking how much water is in the tank initially. So guys, initially that means that no time has passed. So T is going to be equal to 0. You don't have to write that. All you actually need to write down is that we're going to find the volume at 0 minutes or after 0 minutes have passed. Right? So we're going to have to just sub 0 into this equation. Again, this is not really something that you would have to show, but just because it's the first example, let's write it down. Remember, if you look back at this, so what's the answer there? 50. And it is liters, right? They said that the volume is measured in liters. Okay, so initial always t equals 0, whatever it is normally time. They usually give questions in terms of time there. For B, next question. How much water is in the tank after 1 minute of running? So 1 minute, that means that my t value is going to be 1, right? Again, you don't have to write that t is 1. You can actually just write b as 1. It's 1 cubed minus 4 times 1 squared minus 16 times 1 plus 50. You work it out. 31. Thank you. So 31 liters. All right. So then they could now also ask us, I'm actually not sure if that is the next question, but do we notice that in 1 minute, this tank has lost, what's that, 19 liters of water, right? That could also be a question that they could ask us. Let's just quickly go back up to the questions. Determine an expression for the rate of change of the volume of water in the tank. Okay, so now we're getting to rate of change. So that is C. I'm also just going to write it down. Okay, so what I'm going to do is I'm just going to highlight the rate of change because that obviously now is a key word. And guys, what you need to remember is rate of change is derivative. Yeah, and that's it actually. So what we're going to do is I'm just going to rewrite V as T because it's off of my screen now. But if you still have it on your page, then you don't have to rewrite it. But the equation that they gave us was that. So for rate of change, very easy, we're just going to find the derivative. Okay, so you can just write V dash T is equal to, and now we must just find the derivative of each term, which I'm sure we all are fine with. The derivative of t cubed is 3t squared minus, what about 4t squared? What's the derivative of that? 8t, good. And then the derivative of negative 16t is just minus. And that's it, guys. That's the rate of change. Note that we do have a t in this. So now they can ask us, what is the rate of change at a specific point in time? Right, then we're going to have to sub that t value in. So I think that's probably the next question. I'll move back down just now. D, oh, it's not actually. After how long will the volume of water in the tank be a minimum? Okay, so let's write that down. D. Minimum? What do we do when they ask us for the minimum? Maximum or minimum? Remember we put this? Derivative, and we make the derivative equal to 0. Okay, same thing here, guys. So they can't mix the different types of questions together. So just highlight that minimum there. For that, we are always going to make the derivative equal to 0. The derivative of what? What are they asking us here? They're asking for the volume to be a minimum, and then they want us to know after how long. So we're going to have to solve for t. We're going to have to find how many minutes. All right, so we're going to have to say v dash t must be equal to 0. So this equation, okay? Yeah, you do the same thing and then you just have to interpret it if you get multiple answers.
Like it has like a minus part of the part of the
Yes. Yeah. So this is an upward taking process. Yeah. So because this is the A value is positive. So this parabola, if you had to draw it, would look like that. So that's why you missed it. Okay, but we are going to get 2 answers here because it is a quadratic. But then let's just interpret. Guys, do we want to factorize this time? Okay, but let's do it. I'm going to use my little helper here. 3 and negative 8 and negative 16, and I'm getting t minus 4. Okay, there we go. No, it's not. And 4 plus. Oops. So it's 3, sorry, 3t plus 4, yes. 3t plus 4, like that. Yeah, so it's 4 and 4, yes, but it has to be t and 3. Yeah. Equals to 0. Or you can just use quadratic formula, no problem with that. I'm just a bit lazy. I don't feel like writing all of that out now. So now we're getting that t is equal to 4 or t is equal to negative 4 over 3. Now guys, what does t represent? Minutes. Can we have negative minutes? No. So you still have to write down both solutions, but then you must state that that one is invalid. So t is equal to 4. I'm just going to write a little conclusion phrase here, I suppose. So I'm just going to say after 4 minutes, but it's not really necessary. If you don't want to write like a conclusion, but you just need to say that that is 4 minutes. Okay, you just make sure that you put the units next to your 4. Okay, are we fine so far? All right, let me just go back up to see what they're asking in E. How much water is in the tank when the rate of change, sorry, how much water is in the tank when the rate of change is 44 liters per minute? Okay, so E, I'm going to have to do it here next to it. Sorry, were you guys done with that? They're giving us the rate of change. They're telling us that the rate of change is then no, so well, yes, it would be. Yeah, so I suppose you could have solved that one as well. It was the same answer. Okay, E, are we fine? Can we write down E? I can't remember what the question was. How much water is in the tank when the rate of change is 44 liters per minute? Okay, let's write that down quickly. And just move this. How much water is in the tank is 44 liters per minute. So guys, if they're asking for how much water, they want to know the volume, right? So they're asking for what is the volume. Now we have a formula for volume, but in order to get an actual value for that volume, we need to sub in a t value. So how am I going to find what that t value is? Okay. Yeah. Yes, good. Okay, the rate of change, 6 is 44. Remember, rate of change is derivative. Okay, so the derivative of that volume formula is going to be equal to 44. So we need to take our derivative, make that equal to 44, and then we can solve for t from there. So what was that derivative again? Was it 3t squared? Minus 16 is equal to 44. So now we're going to have to move that 44 over to the other side. So negative 16 minus 44 is that negative 16. Yeah. Okay, so now you would use the quadratic formula or you would factorize. I'm going to factorize. And I'll tell you now what we are putting in those brackets. So we have t minus 6. And we have 3t plus 10. So t is either 6 or t is going to have to be negative 10 over 3. Are both of these answers valid? No, we can't have negative minutes. So that second answer is invalid. So that means that after 6 minutes, the rate of change is 44 liters per minute. But they're asking us how much water is in the tank at that time. All right. So now we must still go and take our volume formula and sub in 6 for t. All right. So therefore, the volume after 6 minutes is equal to 6 cubed minus, was it 4t squared? 4 times 6 squared minus 16 times 6, and then plus 50. Run out of space here. Let me just move this across a bit. Plus 50, and then we can just work out what that would be. 26. Thank you. 26, and the volume is liters. So guys, we're working with different equations all the time. You need to remember which one is which. All right, if they're asking for volume, you need to use the volume formula. If they're asking for rate of change, you need to use the derivative. If they're asking for maximum or minimum, you must make the derivative equal to 0. If they've given you the rate of change, then you must make the derivative equal to that rate of change. I just want us to do one more question quickly, which is actually not a question in the original question, but I want us to do it. What is the rate of change of the volume of water in the tank at just which number have we used? They can say at or after. Doesn't mean the same thing. So again, they're talking about rate of change. They're asking us for the rate of change, but now they're saying after 3 minutes or at 3 minutes. So what is rate of change always? Rate of change is always the derivative. So now we need to find the derivative where t is 3. Okay, so if they're asking for the rate of change at a specific time, you need to take the derivative and sub in that specific time, that specific t value. So that will be 3 times 3 squared minus 8 times 3 minus 16. So we're getting negative 13, which we will solve now. Now, guys, here for this type of question, which is why I wanted us to do it, the unit is very important. All right. We need to think what is actually changing. This is the rate of change of the volume. What was the unit of the volume? Liters, right? So you have to write liters, but then you have to say that this volume is changing every minute, right? So it has to be liters per minute. Yes. Yes, you can. Yeah. So guys, if they told us that t was seconds, you would have to say liters per second, right? If they said that volume was centimeters cubed, you would have to say centimeters cubed per minute. All right, this unit thing is very important. Now, why is it negative? It's losing the water. Hey, now guys, in physics, I think you will have to state that. All right, you would have to explain why it's negative. In maths, you don't have to. Okay, if you're getting a negative answer for the rate of change, you can just leave it like that. Full marks, perfect. Okay, we don't expect you to explain why it is negative, so you can just leave your answer like that. If you want to explain, it's fine. Yeah, that's all right. But you won't get extra marks doing that. Okay. I want to quickly show you guys a question from a past final exam that I did the other day, which had to do with like a fly sitting on a wall.